So there's that one. Just recapping for those watching at home. Got this right on the very first try, in case anyone cares. Take the derivative, set it equal to 0. Yep. Take the derivative, plug in 0. There's your equation. Okay? Good? Yeah? See? Okay, what do we have to do for this? Product rule. So the first one times the derivative of the second one plus the second one times the derivative of the first. Would you like to simplify?
No. Sure, why not?
There's not really any simplifying that you can do. Okay? You are such a ADD child. You got it? Okay, what do we do with this one? Everything, right. Product rule, product rule, product rule. First one. First one times the derivative of the second one plus the second one times the derivative of the first. Okay? And that's why it says find f prime in terms of g prime. That's a clue that there's going to be a g prime in your answer. Mm-hmm. Golf? No, we leave Monday morning, 6 a.m. Practice round is Monday in frickin' Spokane. What? We are. Noah and Austin are going. I know, but I am. Okay, number 6. Ball. What do you do? Take el derivativo. Set it equal to 0. Really? Wow. Someone has got a cannon for an arm. Right? Do it with 1,000 feet in the air. The upward velocity of 200 feet per second.
And then what's the maximum height reached by the ball?
Yeah, 1,000 feet.
That's the maximum height?
Mm-hmm.
If it's a baseball, though,
1,000 feet?
Yeah, 1,000 feet. No, that's too high.
Yeah, that's like a 100-story building. What?
No, 1,000 feet. No.
1,000 feet?
No, MLB players
No, dude, the fences are in feet.
they're in feet.
Yeah. Yeah, 100% sure, yeah.
There's no way. There's no way it's 400 yards.
No, but yeah, that'd be 4 football fields. Okay.
Yeah,
Yeah,
there's no way.
yeah.
and it's just throw, not even hit.
Right. I like the physical movement you did. Thrown, not even hit.
No, he didn't hit.
Showing your natural athletic ability.
And let's see how far out he can throw.
That's really high.
Sorry.
Yeah.
Okay, find y prime by implicit differentiation. So that's the thing where you can't solve for y.
I guess 200 feet per second is really fast.
Yeah, that's really fast. So you take the derivative of both of them. And so we have to do the product rule there. Okay? So 17 cosine of x is the first function and sine of y is the second function, right? So you go, let's do this. So first one times the derivative of the second one. What's the derivative of the sine of y? Cosine of y times y prime. That's what implicit differentiation brings into play, is that extra y prime. So first one times the derivative of the second one plus the second one times the derivative of the first. What's the derivative of 17 cosine x?
Negative 17 sine.
Negative 17 sine x. and then that equals 0, because the derivative of 12 is 0. No, because when you're doing x prime, we have not really used the dy dx notation in this class very much, but when you're doing x prime, then it's dx dx. No, it's dx dx, and that's just 1. Okay? All right, so then everybody that has y prime in it stays on the left. Everybody that doesn't, get out of the pool. So 17 cosine x cosine y times y prime equals 17 sine x sine y. And then, trying to solve for y prime. So, divide by 17 cosine x cosine y. 17 cosine x cosine y. So cancel, 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 cancel. Y prime equals, this is fun. 17's cancel. Sine of x over cosine of x is tangent of x. Sine of y over cosine of y is tangent of y. Woo! Okay. All right, number 8, find y prime. So, product rule again. Yeah, we're going to use the chain rule in here when we take the derivative of cosine, yeah. So the first one times the derivative of the second one. So the derivative of cosine is, and then as Brooke pointed out, because it's the cosine of the square root of x, we have to multiply that by the derivative of the square root of x. So that, unfortunately, was only the first one times the derivative of the second one. We have to go plus the second one times the derivative of the first. Sweet. Okay, so then I know that we didn't simplify these much, but there's some really easy basic things that you can do here. The square root of x and the square root of, or x to the negative 1/2, those cancel. So then it's negative 1/2 sine of square root of x plus you don't have enough people over there.
I have like one family over there.
I know, but you would make friends. And,
You know, family. I don't know. It's more family. I like being
really?
family.
Interesting. Good for you. I grew up in Minnesota. I left my family when I went to college. I never looked back. Yeah, that's the answer. University of Puget Sound. Because I didn't want to live in Minnesota anymore. I didn't want to live in Minnesota anymore. Minnesota's stupid. I applied there. Lewis and Clark, a couple schools in California. I actually came out here and visited all 4 of them by myself. So, senior year of high school, which is kind of weird to think about. So I flew to Seattle and then went and visited UPS, and then I took a bus or something down to Lewis and Clark and maybe flew to, I don't know, it was really weird, like my senior year by myself. Why UPS? I don't know. Lewis and Clark, everybody just talked about how great it is to go there because you can study abroad, but I felt like I was already coming from a long ways away, so that was my study abroad. That's why my daughter went there, because that's what she wanted to do. I don't know, UPS just seemed... Yeah, it's okay.
It is. They were directing my sister.
They what?
They directed my sister.
Oh, really?
Well, she's really smart. She's good at
Okay, number 9, a spherical balloon is being inflated. Find the rate of increase of the surface area, S equals 4 pi r squared with respect to the radius when r equals 1. Okay, so what we're finding is S prime, right? But it's the rate of increase, so it's basically like ds dt. So when I take the derivative of this, I put the 2 in front and make it 8 pi r, but then I have to go times dr dt. So it's sort of like implicit differentiation. No, then it says when r equals 1 foot, so I have to plug in 1 for r.
Because wouldn't that be like the chain rule then? It's like 4 pi x squared.
Right.
So you go 2 down to 8 pi r times, oh, it'd be times 31, I guess, right?
Yeah.
Yeah, it'd be times 1.
Half an hour is not bad.
So I think that's all we got. Because you're going to, oh yeah, because they're really close. Yeah.
Brooke's gonna come to my game. Yes.
Oh, so you'll drive.
Wait, you're going where?
Yeah, I've done this Spokane a couple times.
Eastern?
You can come watch me too, Caleb.
And you're going to Boise or Gonzaga? Gonzaga.
Yeah.
Oh, okay.
You just have to tell me when.
Okay.
We'll do most of our planning today.
I'm so excited. So excited.
Oh,
I'm excited for basketball games.
I saw the arms. Yeah, the car is awesome.
I'm excited.
Awesome.
It is. You've been there?
Watch me on TV.
Yes.
I'll be there.
No.
You're gonna be watching.
I would live in the car.
I'm not going to be like scanning the crowd for
Well, we're
Brooke.
like on like the big screen. It's crazy and super cool.
Is it that girl like this?
Yeah, right.
No, I do. I'm doing that game.
She'll be the one chanting defense when we have the ball. Be like, oh, wait.
She'll try to start a
And after during football season this
I
year,
know.
I'm like, stop.
The cheerleaders would start doing that? No, I
I
know.
know football.
Can't stop now, I'm on a roll. Now my roll just ended. No, I couldn't figure out what 4 to the negative 1/2 power was. My brain is not working today very well.
Brian.
I don't feel like that's right.
That's what I got.
You did? So,
No, I got big.
yeah?
Yeah, they pulled all the toilet paper out in this section, but behind it, pulled it back in, back there. That's a great hiding out. That's a great hiding place. It was awesome.
What mall were you at?
We were just at the Walmart in Chehalis.
It's a big one.
We had 5
Why didn't
hours
you go to
to go.
Tumwater? That one's way bigger.
Because it was closer, it was right there, and we had 5 hours to go.
The Tumwater one's bigger than the Chehalis one? They're like small villages. The Walmarts, they're like towns in and of themselves. They're like indoor cities.
Hey, can you just go back here? Yeah, if they hadn't seen
That would take forever.
Oh, it's really fun. It took us about an hour to find where we wanted to go. Taylor really decided to go hide in the bathroom the whole time, which was not there. So we pulled, it was payday. Really trying to hide in the bathroom. Already trying to-
Caleb?
Yeah, thank you.
Now you can't go to. We said they didn't have the ballpark though. I mean, there are pretty weird things.
And then they all decided they were going to go to the Home Depot right next door to pick up the That's a really
Wow.
Drawing, yeah, that's good. That's a good airplane.
I'm surprised we haven't heard more about like Egyptian air or whatever.
You guys been living under a rock
No,
for the
I'm
last
sorry,
couple
we
days?
have, like seen it. I have, and I
Oh.
think it's like a terrorist on a bomb exploded and something. Yeah.
It crashed in the Mexican
It crashed.
Yeah, no, I know.
I
Yeah.
thought Matt.
Oh, I thought, oh, yeah.
Yeah, they get there already got one.
Okay, plane flying
Bernie
horse.
won Oregon, and they tied in Indiana.
Is that today?
No, that's
Kentucky.
Kentucky.
Yeah, but it didn't matter because the way they split their delegates, they each got 27. So
It
what?
was like 0.2%, wasn't it? Yeah. Anyways.
Plane flying horizontally at an altitude of 4 miles and a speed of 465 miles per hour passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing. So distance from the plane to the station is increasing when it is 10 miles away from the station. If I was to measure the distance from the plane to the radar station, I would measure it along
4
this
squared
line.
plus 460, plus 465 plus something squared equals.
Well, this is a rate and these are distances, so it's not going to be this squared plus this squared equals this squared.
4 plus.
Got nothing? Really? Oh, okay. So x squared plus y squared equals z squared, right? And then you take the derivative. So 2x times dx dt plus 2y times dy dt equals 2z times dz dt. What is x? Good. What is y? No, that is, oh, x isn't 4.
No, I'm confused. Isn't X 10?
X is not 10. Y is 4.
Oh, I see.
Z is 10. Yeah, no, I made the same mistake. Right. 465 is dx dt. What is dy dt? What is dy dt? What's the change in height divided by the change in time? Yes, it should be. So that means it's 0. And dz dt is what we're trying to find. So we're only missing one point, or one piece of information, and that's x. No, because you subtract. So it's 100 minus 16. So x is the square root of 84. Okay, so plug all that crap into that derivative. So 2 times square root of 84 times 465. I don't have to do this, right? Because the dy dt is 0, so that's going to cancel out. Equals 2 times z, which is 10, times dz dt, which is what we're trying to find. So dz dt equals this divided by that. So the 2's are going to cancel. 465 divided by 10 is 46.5. So it's going to be the square root of, I guess you put the number first, it's going to be 46.5 times the square root of 84, which is, 46.5 times the square root of 84 is 12. Nope. Way bigger than 46.5. 426. Caught in my leash. Got to get a Bluetooth one next year. Record every day, every period. In my last year of teaching. Because then the years after that, just come in and push play.
Sit there and play Candy Crush?
Yeah, and yell at the kids. Quiet down, listen to the lesson. If you have a question, ask your neighbor. Okay, 13, find the limit if g of x equals x to the fifth. Oh, ho, ho, ho.
So I put x to the fifth minus 32 over x minus 2.
Okay, so the limit as x approaches 2 of x to the fifth minus 32 over x minus 2. Okay.
And it was that 0 over 0 thing, and you put 2 in there, so I was thinking about taking the 0.
Oh, yeah, you want to do that? Okay, let's take the derivative and try. Yep. So that'd be 5x to the fourth over 1. Uh-huh. If you put 2 in there, you get 16 times 5, which is 80. This is, boys and girls, cats and kittens, ladies and germs, the definition, one of the definitions of the derivative. So what this question is really asking is, what is the derivative of x to the fifth when x equals 2, which is what we ended up with here in the end. The other way that you could do it is this thing right here. You can factor out an x minus 2. And this is a little cumbersome. I don't really want to do it, but you could use synthetic division to, yeah. Oh, synthetic division, don't ever say ooh about synthetic division. What? Yeah. Okay, number 14, a company makes computer chips from square wafers of silicon. It wants to keep the side length of a wafer very close to 17 millimeters. The area is a of x. Find a prime of 16. Did I say 17? So the area of a square is, but it's a square, so it's that, right? All right. So the derivative of that is 2 times s. So
Okay, what was that question even asking?
I don't really know. I started watching that show Silicon Valley though. It's interesting because it's about these nerds that like come up with a supercomputer program, and then everybody wants to give them all their money to, you know, and so you always like read about that and you think, oh, that'd be so awesome, but it's actually like really stressful. Like they have to do a lot, you know what I mean? Like he comes up with the idea and the guy goes, okay, well I want to invest in your idea, I'll give you like $10 million. And he's like, oh, super excited. And he goes, okay, we'll meet next week. And he goes to the meeting and the guy goes, okay, so what's your business plan? And the guy's like, what? What are you talking about? And the guy's like, you didn't think I was just going to give you $10 million without any, you know, and so they have to hire all these people and, you know, figure out all this stuff. And but he's super nerdy and.
It's just hard to kind of balance both being a nerd and then also figuring out.
Yeah, no, they hire someone else, so this someone else is like working with these programmers that are super weird and nerdy, and he's trying to create this like business climate, and they're all like, you know, mad at each other because he ate my cereal and that kind of stuff. He's like, okay, well, we need to really focus. We have a startup due, and you know, so I don't know. It's kind of okay. So you have to do product rule, and we have to do implicit differentiation. So first one times the derivative of the second one, and the derivative of y to the fourth is 4y to the third times y prime. So that was the first one times the derivative of the second one when the x's and y's are mixed up together. Plus the second one times the derivative of the first, which is just 1. So that's the derivative of that first term. Plus the derivative of x squared y is the first one times the derivative of the second one, plus the second one times the derivative of the first, equals the derivative of x is 1, and the derivative of 3y is 3y prime. So chew on that for a minute.
So even if the x and the y aren't touching on the right side, you still have to do the y prime just because you what you did once.
Yep, once you go down that road, you're committed. No going back. Okay, now, same thing as before. Everybody with a y prime in them goes to the left. Everybody without goes to the right. So this becomes 4xy cubed times y prime. This is x squared, bless you, y prime. And this is negative 3y prime. Okay? And then this 1 is going to stay here, minus y to the 4th minus 2xy. I think I got them all. Yeah, I'm going to technically first factor out a y prime. So y prime times 4xy cubed plus x squared minus 3 equals 1 minus y to the 4th minus 2xy, and then divide by all that stuff, so 1 minus y to the 4th minus 2xy over 4xy cubed plus x squared minus 3. That's a good time, huh? Yeah. Okay?
So y is what?
Mm-hmm.
What happened? This from the original?
Yep. Because it's the first one times the derivative of the second one plus the second one, so the second one is y to the 4th times the derivative. Okay. You're sure welcome, Logan. Thanks for asking that probing question. Good? Oh, first and second derivatives. All right, so first derivative is, what is it? Low d high, which is just 1, minus high d low
Times
over the square of what's below. And so now, since we have to take the second derivative, I'm going to simplify it a little bit, but super easy simplifying, yeah? The x's cancel, so you just get 3 over 3 minus x squared. Uh-huh. So the second derivative, low d high,
that's 0.
right, so low d high is going to be 0, so who cares, minus high d low, so the derivative of, whoops, that squared is supposed to be on the outside. Was I confusing you there? Yeah, okay. I would have been happy if you did. So low d high comes out to be 0 minus high d low. So what's the derivative of 3 minus x squared? 2 times 3 minus x to the first times negative 1. Over the square of what's below, so 3 minus x. Yep. So 6 times 3 minus x over 3 minus x to the 4th, which is really 6 over 3 minus x to the 3rd. Tehran. What? Yeah, where should it be?
So
Making a
we're
con-
passing time a little about softball games. We're playing cards. Tony steals my card. First 3 cards he gives me with sixes, so 3 sixes in a row. I'm like, put the card in the man, not playing this now. So I roll up.
Why? That's a winning hand, dude.
No, that scared me. I don't care. So I played the next round. I played the next round.
Three of a kind.
My first 3 cards the next round were 7s. I was like, all right.
Huh. Should have left the fast pitch game and headed straight for the casino.
I want to go gambling.
No.
You have to do it at least once in a lifetime.
No. No.
I won like $50 betting one quarter.
My aunt went over to the casino a few weeks ago, went to the machine, and it was $50 in it. Right? She decided to still play anyway. No, I think it was
Just for fun. I mean, I just want to do one.
Uh-uh.
You're almost money that you're okay with.
Yeah, I wasn't able to do it.
Yeah, exactly.
Okay.
You gotta bring be a ticket.
I'm already planning my 21st birthday in Vegas. So, no, seriously, my mom is to be playing it like in this house. No, that's the problem. If people have that mentality.
I don't want to like set aside money that you'll go and spend.
No, I just want to keep up because I want to spend enough money out there and actually use.
No.
I'm not going to do it.
Tax on the ignorant.
But
How do you think they?
If it's money that's just okay with losing though.
But you could go in there with $20 and be done in like half an hour, and then you go, well, that sucked.
I know, but I just want to try it at least once in my lifetime.
It's no fun.
No, they don't. No, nobody wins consistently at casinos ever. They're lying to you. No, they're lying to you. The odds are always stacked in the casino's favor. That's why they have those huge fancy buildings. There's no possible way that you can go. You can go, and what happens is people go, and the only time they tell the story is about when they win. That's okay. And they never tell the story about when they lose. Nobody wins every weekend except the house. Yeah, can't do, it's not. The odds are stacked. If you could go and win every weekend, then they would be out of business. That is a weird one. Oh, so sorry, we want to go dy dt here. So this time everybody gets derivative of their own selves. So the derivative of 2x cubed is 6x squared dx dt, and the derivative of 5x is 5 dx dt. And then they say dx dt is 3 and x equals 5. So plug that crap in there. Unless they're going and they're playing in like tournaments against other people, like they're going to a poker table or something, you know. Yeah, but when you're like playing machines or craps or roulette or whatever, right? And so you only, doesn't happen all the time. Okay, so 25 times 6 is what, $1.50 times 3 plus 5 times 3 equals 450 plus 15, so 465. Oh my gosh, we almost are done with class? Yeah, you guys are being mean to me. Uh-huh.
So I remember we were going over this. I complained because I don't like the dx over. I don't like that. What was the other thing that you wrote instead of that?
You could just do like y prime or x prime. But this problem says dx dt, so you kind of have to. You could still do it, yeah. But I'm feeling like as a teacher it's time to sort of pull off the Band-Aid, and you're going to go to class next year and they're going to do this, and you need to be ready for that. It's not that big of a deal. If you're hung up on that, then... okay, oh wow, man, really? God, I hope all right. The volume of a cube is increasing at a rate of 10 cubic meters per minute. How fast is the surface area increasing when the length of an edge is 30 centimeters? So what is the formula for surface area of a cube? No pi's. No 4's. No r's. It's a cube. No radius. No pi's. 6s squared. So now I have to take the derivative of that. So the derivative, how fast is the surface area increasing? Okay, so the derivative of that is 12s times, sorry Colby, ds dt. Well, let's see, how fast? So we know that s is 30. We're trying to find this, so we have to find ds dt. Well, we haven't used this yet. We haven't used the fact that the volume is increasing, right? So what's the formula for the volume? 4/3. No, it's a cube, dude. It's a cube. Side times side times side. S cubed. So dv dt equals 3s squared times ds dt. What is dv dt? 10. What is s? Right, so that's going to be 900. So whoops, so you can use that to figure out what ds dt is, right? So it's 2700, 10 over 2700, which is 1 over 270. And then you can plug that in here for ds dt and plug in 30 for s and come up with an answer.
Which is
What is it? So you went 12 times 30 is 360 over 270. Like that a lot. And then 90 goes in there, yeah, so 4/3. Jake, weird. Which is weird because the volume of a sphere is 4/3 pi r cubed, so. Yeah, she was just trying to tell us the answer in the end, yeah. All right, last one, easy one. I don't know why this is the last one. There should be a hard one in the end, shouldn't there be? So low pi minus I below over the square piece of cake, right? You guys could do this stuff. Yeah? You learned something this year, right, Tiana? Yeah. Did you just go woohoo? Spring break.